Welcome back to section 11.3. The last thing we're going to talk about is something called the discriminant. So in our quadratic formula, the x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is just this part, b squared minus 4ac, okay? That's the discriminant. Okay? And the discriminant is nice because it tells us what kind of answers to expect. Because you're taking the square root, if that discriminant is positive, you know it's going to be a real number. If it's a perfect square, you know you're going to be able to take that square root, and then you're going to get a rational answer. You're going to get some sort of a fraction or some sort of an integer kind of an answer, okay? If you have a positive value, but it's not a perfect square, well, you're going to get an irrational solution, but it'll be real. Okay, you'll get two irrational answers. If you get a 0 for your discriminant, if you have a 0 in here, you're going to get a plus or minus the square root of 0, which is just going to give you one answer, because adding 0 and subtracting 0 give you the same value. So you get one answer, and it will be rational because it'll just be negative b over 2a. And assuming b and a are integers, that's going to give you a nice rational solution. Remember that rational means it can be written as a fraction, okay? If that discriminant, if the b squared minus 4ac, if that part of it is negative, that means that you're going to get some sort of an imaginary number when you take the square root, which means that you're going to get a complex solution. You're going to get a real plus or minus an imaginary number. So you're going to get two answers, the plus and the minus, and they're both going to be complex numbers. So what I'm going to ask you guys to do is not solve everything. I just want to find the discriminant of each one, and then we're going to decide how many solutions we're going to have and what type of solutions the equation will have. That's all we want to know, is what kind of answers am I going to get and how many answers. Okay? So this is example 2a. The first one I have is 2x plus 6 equals x squared minus 2x plus 1. And the first thing I notice is it's not in standard form yet. Well, let's get it there. Let's subtract 2x from both sides. And let's subtract 6 from both sides. So then it equals 0. Then we'll have x squared. Negative 2x minus 2x is negative 4x. 1 minus 6 is negative 5. So we have an a value of 1, a b value of negative 4, a c value of negative 5. So when I am looking at that discriminant, the discriminant is just the b squared minus 4ac part of the equation. So the discriminant for this first one, I'm going to do b squared, so negative 4 squared, which is 16, minus 4 times a, which is 1, times c, which is negative 5. All right, I'm going to do multiplication before subtraction. So 4 times 1 is 4, and then that 4 times negative 5 is negative 20. Then I'm going to subtract negative 20, which is the same thing as adding positive 20. 16 plus 20 would give us a discriminant of 36. All right, so if it helps in your brain to be like, what kind of answer am I going to get? Well, we're going to do the plus or minus of square root of 36 in the equation, aren't we? So 36 is a perfect square. It's positive. We're going to be able to take that square root really nicely, right? It'd be plus or minus the square root of 6, or plus or minus 6, which is really nice. So what we're going to have is a positive and a negative, right? A plus and a minus version, so we are going to get two solutions when we do the quadratic formula. It's a perfect square, so we're going to get nice integer answers, which is going to relate to a rational solutions. Okay? We'll be able to write them as fractions. Okay? So we get two solutions, and they will be rational. Let's try another one. In part B, yet again, it's not in standard form. Yep, let's get it there. So I've got 2x minus 1 squared equals x minus 2. Now keep in mind when we have that parentheses squared, that's the same thing as 2x minus 1 times 2x minus 1. And I'm going to need to distribute. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x. And negative 1 times negative 1 is positive 1. Then I would love to get everything on the same side of my equation so that it equals 0. So I'm going to subtract x from both sides, and I'm going to add 2 to both sides so that it equals 0. Okay? On this left side, I'll still have a 4x squared. When I combine like terms, negative 2x minus 2x is negative 4x. Minus another x is negative 5x. With my constants, 1 plus 2 is 3. So now I'm in standard form. I can see that my a value is 4, my b value is negative 5, my c value is 3. So my discriminant is just that part under the square root. It's b squared minus 4ac. We're not taking the square root of it. We're just doing the part underneath. So b squared would be negative 5 squared. Negative 5 times negative 5 is positive 25. Times 4 times a, which is 4, times c, which is 3. And I'm going to do multiplication before subtraction. 4 times 4 is 16, and 16 times 3 is 48. So now I have 25 minus 48. All right. If you do 25 minus 48, we're going to get a negative value. We're going to get negative 23. So, having a negative discriminant, here's the discriminant. Having a negative discriminant tells me that I'm going to have two complex solutions. So I'm going to have two answers. And they're both going to be complex because when I take that plus or minus square root of negative 23, I'm going to pull out an I, right? And because I have an I in my answer, it's imaginary. We're going to do a real number plus or minus an imaginary number, which gives us complex solutions. Now it's your all's turn. You get to try one and show me how much you've learned.